All right, so this is a second attempt. If anyone was watching earlier, we had a situation where the Zoom meeting wouldn't work, but I have an actuator. It's a RSA actuator with an ACSI and reverse parallel orientation. That's the hardware. We have a power supply that's wired into the large cable, and then a USB cable on the communications port. And so that's wired back to the computer and to the power supply. So we can watch the video there as I move this unit out and back. We also have on the left side of the screen the Tolomatic motion interface software, which isn't connected yet, but once you get the hardware, you'll need to get the software. And in order to do that, you'd want to go to our website, which you should be able to see now. And on our website, you would go to the info center and then to the software under product support. And within that info center, you can find the drop down for software and firmware, and it shows the current software packages. This is where you'll find the Tolomatic motion interface version 3.22. That's the current version. And so we'll want to download that and install it. Once you've installed it, then you should see something like this. It would be an icon that you'd open up and it would show you this screen. And we're currently not connected. So once you have power on the actuator, on the motor, and you have the communication set up, you should see a blue light. You can kind of see it on the port there. That should be a blue LED that turns on with power. Once you have that powered on, you can connect using the connect button. And you'll see that the information from the motor is then pulled into the software, so you can see things like the product code, the model number, the firmware version, the Ethernet IP address if it had one, a MAC ID address or MAC ID. That's all listed there. And then there's a picture of the motor that you're connected to as a reference as well. So at this point, we have communication to the device. A lot of times when it ships from Tolomatic, it'll come in with information in it. You can see this. These tabs here don't have anything required in them. So the Tolomatic symbol here, this little ball moved down to the home setup tab because it wants us to fill in information there. So a lot of times when you get a full system from Tolomatic, we had tested it and it would have some of this information on the actuator built in. But if you didn't, then we would be able to start from 0. And I'm going to just show that real quick. So I'm going to restore the drive to factory settings through the file. And that's going to restore the drive. And it says the bus voltage mismatch is detected. It thinks it's at 24 volts and it's measuring 48 on the incoming power. I do have a 48 volt power supply. Do I want to ignore future mismatches? No, because that would be bad. The drive is restored. And now it's giving me an over voltage, and that's because of this voltage mismatch here. So if I have a 48 volt power supply, I want to turn that to 48 volts on the bus. So once I do that, then the drive is going to recognize that it's running at 48 volts. The over voltage indicator should still be on because it still thinks it's in a, it still thinks that fault is active. We need to clear the fault, and that's done through the enable. But we don't need to do that at this moment. So first of all, you can see that this symbol moved back to the actuator tab. So now if we click on that, there's nothing in this string for the actuator. So now we'll go through and select the correct actuator and fill this in. So you start out by clicking on the product family and then the size. This is a RSA 24. And then you pick the screw type, and it just so happens that everything's listed right on the side of the actuator right here in the label. So we have an SN04 on this particular device. I could use metric stroke or in inches. So I'm going to pick inches, and this will be 6 inches a stroke. It's a reverse parallel. It's 1-to-1. So I select that. And again, this is right off of the label. It gives you some motor options here. I just have the standard 23 frame motor, so I pick that one. No gear heads or brakes added to this one, so I don't need to worry about that. And then now you can see that the symbol moved over to the next tab here. So the mode select tab is now highlighted with the symbol. That means I can move over to that one. And I'm going to move from left to right as I work through this, obviously, but we'll get through it. And by the time we get to the end, we should have some motion. So now it's asking for an operating mode. And if you've listened to some of the other ToloTalks, we talk about these operating modes in the ACS and TMI presentation, but this, you either have index move mode, analog position, pneumatic, or Ethernet IP as operating modes. And if you had a different protocol for the communication, maybe it's Profinet, then this would obviously change to that version, Profinet or EtherCAT. So I'm going to select the index move mode just to get started here. And we can pick that. It shows us the drop down for 4 move commands with 2 inputs, or a basic indexer, which is not ready yet for production. But if you pick this 4 index or the 4 move commands, you have 2 inputs that can be used in binary to select 4 of those different move commands. So we'll just pick that real quick to give it a try and see if we can get motion to start. All right, so now you can see that we've jumped all the way down to the home setup tab with the symbol. So that means the IO, the fault, the safety limits all have data in them, and we can just touch on them real quick. The IO tab, for starters, has a digital input section. So there's 4 inputs for that. And we right now have enable, start motion, home, and a move select indicated there. So if you needed 2 inputs, you'd have to take over one of these other spots here and make it a move select instead of a home, for instance. So I could switch this to not configured, switch that one to not configured, go to MS1 there, MS2 here. And now I have 2 inputs. I can enable, it'll home on enable or home on power up. So I don't necessarily need an input to command the home. Then there's a start motion, you need that. And then if you wanted 4 moves, you would need 2 inputs. So I have those 2 inputs available. For outputs, we could change these to whatever fits the application. Could be motion complete, home complete, or fault. Fault is a pretty common one in case something happens, you want to be able to stop some other process or turn a light on or something like that. So you can do that. And you get a couple of outputs with that, with this device. So there's a couple spots for that. If you have a brake, then you'll want to use this brake output. And that brake output actually is, it takes over one of the digital outputs and it would go to a relay in a cabinet and back to a brake. So it's a little bit different with the ACSI than it would be with like an ACS. The drive is non-integrated and it has enough current on the output to run the brake directly off of the drive instead of going back to a relay. But if you had a brake, you could use this brake output. In this case, we don't. So then moving on, you have the faults tab. This is just showing the list of faults. Safety faults are easily resettable. Critical faults typically require a power cycling of the drive. So you have to turn the drive off, turn it back on again, and it'll clear those faults. And a lot of times these ones are a little bit more critical, like the over voltage, that's usually bad. It's going to shut it down. Under voltage, sometimes those you can clear without power cycling, but most of the cases, critical is going to require a power cycle. Okay, and then moving on, you have the safety and limits tab. This is where some of the specs get set for that particular application you're working on. So for instance, in position, you might have a situation where you want to have the actuator in a certain zone before you say it's there. And if it's moving fast and you want it to return quickly, you might have this in position be a larger number, because then it'll get there into that zone quicker and then trigger the move complete quicker, and then allow you to return back the other direction as quick as possible. Okay, so then contrary to that, you have the following error or position error. And right now this is set at just under 200 thousandths of an inch. Position error is going to be the error during the move. So that's if you started a move from 0 to 5 inches or something, during the transition from your 0 position to the 5-inch position, if it exceeds this 200 thousandths of an inch, then you would get a fault, and it would say position error. The fault light or fault output would turn on, and then you'd be able to see what happened. Maybe you ran into something. Maybe there's more resistance than was expected in the application. It would slow down the actuator from moving, and then once the position error exceeded 200 thousandths, then you would stop because of that fault. Okay, so also listed here, there's a settle time. So that's once you get into position, and then there's a force move settle time. So that's during the force move. If you have longer time to settle out the force, it just means that you're applying that force for a little bit longer before saying, yep, I'm in position and I'm done now. So if you set that to a lesser number, typically then as soon as the force spikes up to that setting, then it would trigger the complete move complete light, or the output for that. All right, so then on this side here, the following error, there's also a velocity error that goes along kind of with the position error. If you're using a velocity mode, a velocity error would be taken into account there. All right, so then the motion limits underneath, you have velocity, maximum XL, decel, and then some current limits. So obviously you could just change these to limit the capability of the device. So the peak current and the continuous current could be reduced in order to create a safer solution if it's could cause damage or something like that. The peak current duration, this is going to be how long that peak force can be applied. And so right now we're at 1,000 milliseconds, and you could turn that up to probably maybe 5 seconds in a lot of cases, but you have to have the cooling after that in order to allow the motor to cool off enough so it doesn't overheat. Underneath that, there's the negative and positive limits for software. If you turn this up, then you can't move beyond the minimum distance there. So you could change these. These are like limit switches, but they're built into the software. Once you home, you know where the 0 is, but if you were operating off of that 0 point and you didn't want to exceed some limit because there's hardware in the way, then you would dial back maybe this positive limit to allow that to happen. All right, so we're going to move on to the home setup tab. The home setup tab, you have a method to a hard stop. If I had switches hooked up and in the inputs, then I could see an option here of homing to a switch as well. But since I don't have any of that, and I'm running in actuator mode or linear motion mode, it only has a hard stop as an option. So that means the actuator is going to drive into the hard stop and call it 0 based on these parameters here. So I could go in the positive or negative direction. Right now I'm set up for negative. And I could go at different velocities. And also there's this offset of 0.04 inches basically off of the hard stop. So it's going to move away from the hard stop. And then I have a percentage of force here at 40%. If I went at 100%, if I went at 100% here on the force, then what would happen is you'd use everything that the motor has to push against the end of the stroke, and that's probably not a good thing. So a lot of times what we do is set this force value at about 15% over what the application requires. So if you had a situation where you're lifting a load and you had to lift the load in order to find the home, you'd want to have the homing force at about 15% more than what's required to actually lift it. So let's just try right now. I have it set up. I have it powered on. If I click this home button right here, on the right side, it should home, and we'll see if it goes the correct direction. I have it in negative. Negative is typically the retract move. So if I click that button, you can see it's extending. We consider that to be backward. So it's going to extend out to the rod end, or the end of stroke. I'm going to pull the stop sign back. This is a always on top stop that shows up here, but what I could do is flip the direction to positive, and then it would come back when it homes. But that's not correct for this actuator orientation. So since I have a reverse parallel, I'm going to want to actually stop here and go back to the motor tab. If I go back to the motor tab, this is where all the information is for that motor loaded in. I don't know if I actually touched on this, but if I click this check box for reverse direction, it reverses the motor orientation. And so instead of operating counterclockwise or clockwise, it'll operate the opposite direction. So clockwise to counterclockwise, for instance. And so this tab shows all the other parameters for that motor, but I'm just reversing direction. So I click the checkbox, and now I'm going to go back to the home setup tab. It said it was homed, but now I'm going to try to home it again because I just reversed direction. I just clicked the checkbox for that on the motor. So now I'm going to home back the other direction. You can see it's coming back. I'm still going negative, and this is the direction that we want to go. So backing the thrust rod into the actuator. That would be considered negative according to the actuator thrust rod anyway. So now we're homed, and it came off the hard stop just a little bit. And it says it's good. We can move on to the mode setup tab now. Position is 0. I go on to the mode setup tab. We have our 4 motions here underneath on the table on the move definitions. So we'll fill that in. Up on the top, you have software controlled and then digital input controlled. So I don't have any inputs at this moment wired into the IO port, which would also be on the top here. I don't have anything wired into that, so I'm not going to use this digital input controlled selection. But if I did, I could do that and test the inputs. So right now we'll do software controlled. There's also this test sequence that we can do, and I'll show you that in a little bit. But first, let's fill in this table here. So under the move type, you can select absolute, incremental, positive, negative, home. There's a force move under here, and a couple extra ones that don't usually get used. But we're going to pick an absolute. We're going to use this first position as 0. The velocity is going to be, let's call this 5 inches per second. Acceleration 20, decel 20, force 100. And it's just like an Excel spreadsheet where you move around like that. But I'm going to put in some numbers here real quick and just get some motion happening. And we can change it up a little bit. Maybe let's do it an index move. We can increment positive, and we'll go by 0.25 inches. And we'll call this 2 inches per second. And 50 on the XL, 50 on the decel, 100 on the force. And let's just try that. So I have these moves. I can pick one and just execute that move. I was already at 0, so it didn't go anywhere. Now it's extended out to 5 inches. If I hit this one, I might be able to go a little bit farther. I'm getting close to the end of stroke. Let's just see. Goes a little bit. Can't really see it on the screen, so I'll bring this back to 0. And if I put it into this sequence up here, then we can run it out and back and maybe do a couple different moves here. And then we can cycle continuously and just set it going. So now it's going to run between those positions. It'll do a couple of index incremental moves and then come back to 0. You can hear it running away back there. But if I leave this running, I can't disconnect the software and allow it to keep running. This is running only off the software. So we would need a PLC to trigger these inputs, and that's why this digital input controlled is there. Okay, so now it's operating. I'm going to stop it real quick so we can talk through the next piece without that thing barking at us. So if you look up in the top here, there's a bunch of different icons that are used throughout the software here, and it's available there. If you, first of all, notice that this is a write to flash. That's going to write this program to the drive's flash memory in the back of the drive there. So it's writing it in. You also have these features restore and write on the toolbar up on the top. So if you write the settings in and operate it, then you can restore later. You could also save it, open it from a file, and go through those features. But just working your way through the list, the ones that we usually use the most commonly is going to be this motion manager, which actually happened to open up on my other screen here. So let me just pull that over. So there's the motion manager. It has the disable and home, the status of that, and then also a motion profile that's available. You can plug in the motion profile and execute a move right off of this screen. Jog, positive, negative, absolute moves, or incremental moves. You can do all those right off of this motion manager. There's also a tuning filter. You can see status, digital inputs and outputs, and then this oscilloscope feature that's available. So if I just click on one real quick, like this oscilloscope, I can pick some channels here. Let's do actual. Let's do commanded position and actual position. Actual commanded position and actual position. There we go. I can read now. Commanded position. Okay, so I got both of those on there, and I can also do like a bus voltage or something like that just to fill up the graph. And if I do an auto trigger, it's going to start listening. And so there now I have this this graph going. But if I start the cycle on our table, now it's running out and back. You can see it on the right side, extending and retracting. This software oscilloscope is going to update shortly after the cycle happens, but it's a very rapid oscilloscope to follow. And you can see the current position and the actual position are following each other. If you saw some variation in that, then there'd be a problem with your position error probably. Bus voltage is staying pretty flat at 48 volts. If you saw spikes bigger than these, like going up 1 or 2 voltages or down a couple volts, you'd probably want to consider some voltage regulation. So things like you have shunt regulators that could protect the voltage from spikes, or you could have a stronger, larger power supply that allows you to pull more current from it and avoid the low voltage scenario. There's a couple things there that you could look at just by operating it off of this software and through the oscilloscope. So the last thing here, we'll go back and look at the modes, but for these features on the toolbar, I just want to show you this tuning feature, and it popped up in the other window there, so I'm dragging it over. But you have this tuning filter that's available with all the servo motor versions. And so since the ACSI is a servo motor, here's the tuning filter that's available for it. So you can see it. We have the loops, current, velocity, and position loops here available. So you can adjust those. We typically stay within the velocity and position loop tuning for most of the applications that we've worked with, because the current is set to the motor, the current loop. And usually that's done when we add a motor to our line. We add a motor to the software, so we'll add that current loop into the software here. One of the biggest things is making sure that the bus voltage is correct, and then this reflected inertia. If you bring this bar to the right and increase it, it's going to make it more rigid, and you might hear some whining out of the motor. If I bring it to the left, it's going to bring it down and more soft, and then it'll be when it's softer tuning, then you'd have a situation where the actuator might not be able to keep up, and you might have a position error that occurs. And so that would be bad as well. So we have it at 5 right now. It seemed to have been working pretty well, extending and back without having much noise or problems with the motion. So I'm going to leave it there for now. When you adjust here, this is the velocity loop tuning. There's a crosshair, a red crosshair. You can adjust this thing all over the place. But for the most part, if you go up to the top right corner, it's going to be more rigid and more responsive. Bottom left corner is going to be softer tuning, less responsive. So just keep that in mind when you're in the tuning zone. I just went back to the center there to try to get it back to where it was. And you can adjust those numbers if you saw, as I tweak it here, the numbers down below change, so you can actually see the value instead of just clicking on the graph. All right, so that's the software. You can run it off of here as well, just to try it, and it'll graph on the right side. So you can see that change as it works. But there's all sorts of different things that can happen in the tuning filter, and it just gives you an idea that it does exist. There is tuning available, and if you need help, there's a quick reference guide here. So tuning help, quick reference. So this quick reference is available in there. It will help you with your simple tuning processes that you're working on. So it has the initial tuning, basic, quick tuning, and some more advanced tuning situations that you could work through. Just know that that's available. So that's about it for all the tools. There's a user unit adjustment that you can do that's pretty quick and easy. But for the most part, if you have any trouble, you'll want to go to the help, and you'll see that there's some documentation there. There's a Tolomatic motion interface software guide that I would recommend to start out with. Otherwise, the applications team at Tolomatic is more than willing and able to help with this product line and the Tolomatic motion interface software. So if you got this demo and you downloaded the software, I would say it's about 15 to 20 minutes at the most to work from left to right through the software to get motion, show your customer or show the engineers that are looking at it how this thing operates, and show some examples of the motion. And don't forget that there's also other modes that are available. So you have the index mode, analog position mode, a pneumatic mode that's going to operate just like a pneumatic cylinder, and then you can run off of that Ethernet communication as well. So gives you a quick rundown of the software, and hopefully it was beneficial for you. But if you have any questions, feel free to contact us at Tolomatic, and we can help you with that. Again, this is Joel Beckla, Tolomatic Applications Engineering Supervisor, and thanks for joining us today.